Hello, can you hear me?
Yes.
Excellent. I'm not at my usual location today, so basically things may be a little off. I'm going to drop a couple of links in the chat as usual. So the meeting minutes would be the first link. So I started putting a few things in, but we'll probably need a scribe. Just give me a second. So, okay, here's the link to the meeting minutes. If somebody could be the scribe, at least put in the attendees, etc. And as usual, just giving people a couple of minutes to join so that we can jump right into it.
Mark,
Yes.
while we're waiting, I would like to introduce my colleague Ari from Google. Unfortunately, this is a bad timing for me, so I won't be able to join the meeting. So I would like to invite my colleague Ari to represent Google here. I just want to give him an introduction.
Okay, thank you so much. Welcome, Ari.
Hi, nice to meet you all.
All right. Okay, well, I would say let's begin. We have plenty of people online. There are a couple of things I wanted to discuss, and I put them in the meeting minutes. So specifically, I'm staying away for now from topics that should be discussed in the attestation SIG. Okay, and also I will not be able to attend today's attestation SIG meeting. It would be wonderful if some people from the school could attend. I looked at their agenda for today, and they will be discussing future topics. So that's a fantastic time to advocate for the things that come out of trustworthy workload identity. Then I want to do a quick recap of requirements. And I added a requirement in the attestation side of things that I wanted this group to review real quick. And after that, I believe that our requirements are complete and we should work to commit them to GitHub so future changes will be tracked via pull requests. Finally, in the remaining time, we'll take a look at the reference architecture. I made a proposal in there specifically related to the architecture of workload identity procurement for short versus long-lived workloads. And then as I was writing it, I discovered a pretty massive hole, or at least I'm afraid it is. And I wanted to sort of have a discussion around that specifically, and also my proposal, and also a few things related to that. As always, anyone's welcome to bring their own topics. We'll handle them today, or we'll put them on the to-do list. So let's jump in. So the first thing I want to do is I want to put the workload identity requirements again. as usual. The link is in the chat. Here it is. And then I'm going to share my screen, and you can watch this. Requirements. Awesome. All right. So specifically, what I added is this. Number 15. So take a minute to review this. This is something that I believe just needs to be handled explicitly. It is very much a governance and deployability requirement from institutional perspective. So specifically what this talks about is when we attest a workload, the workload is really something that is independent of the hosting environment. This is what confidential computing provides, that you can run it anywhere so long as the code signature is there, or sorry, I mean the hash of the measurements matches, you're good. However, regulations will also have something to say about, say, the physical location of the platform, and maybe some other things. And that has to be obtained by testing the platform itself, which is not part of the workload. And again, this is not, the requirement is not a document where we talk about solutions. It is a document where we basically list all the things that the reference architecture needs to address. So I wanted to make it explicit that we cover a situation where the workload identity claims in the workload identity handle both the information about the workload itself and the information about the platform on which the workload executes. So I wanted to see if there are any issues with adding this. If not, I would simply accept this change. And after that, we'll go through the process of publishing this document as in GitHub somewhere.
So Mark, when you say claims, what do you mean here? Because claims have a different meaning in different context.
Attribute value pairs that you get in SAML, basically. Location,
Sorry?
we call that. Like in SAML, you have claims, attribute value pairs. Can you not hear me well?
No, I think now I can hear. There was some audio. Initially, I think it was not clear what exactly you mean. So you are saying it's a key value pair, but about the location of the physical server, you are saying, or
about the
much
platform
more
on
wide?
which the workload executes. Well, a physical location is an example, but there could be others. Maybe there could be a claim about this workload is in a physically secure location. I don't know. Like it could be anything. But effectively, what happens is you attest the workload separately. You attest the platform, perhaps with a TPM, and then you combine the claims from two attestations to arrive at the credentials for the workload.
So I'm in agreement with the wording here, but I wonder if we shouldn't then clarify a sub requirement for the architecture to define which of the claims are persistent and impacting the identity when it's going to migrate, for example, from one server to the other, and which are really classified as redeployment. Because if you go broader, I would assume some of the claims might be like the identity of the individual server you're running against. And some relying parties might care about their workloads never migrating outside of the pinned environment, but some relying parties might be okay with, for example, being within the certain geo-boundary. I just think we should define those groupings of claims.
You are correct. Let me respond to that specifically. So we do talk in the requirements about migration, and that is related to this. So clearly, right? So when the workload migrates from one platform to the other, the claims about the workload might change. And I forget where. There we go. Look at requirement 8. Okay. Here we basically say, look, workload migration might happen. So in the data center, this is pretty common, right? So if you're upgrading data center hardware, then you migrate your workloads. Usually it's done in kind of a silent way. So the workload doesn't even notice. Some silicon, like AMD silicon, has primitives for initiating migration to another platform. So what this requirement states, and by the way, let me say, requirements are flexible. Like we can change them. I'm just speaking to what's written down right now. Okay, so nothing's cast in stone. But the way it's written right now basically says, look, if your migration doesn't change the claims from the standpoint of the relying party, then you can treat this as migration. And if yeah, I do not know where the noise is coming from, Alex. I apologize. I have no idea. I may try and move from my headphones to, or maybe it's coming from someone else.
I don't think it was you. I think it just went away. Maybe it was Nicholas. I don't know.
Yeah, I apologize. I do not know what's going on. But if the claims change, then you need to treat this as a redeployment, right? So again, maybe this needs to move into the attestation land, right? But it is spoken to.
Sorry,
Yeah,
Mark. I don't think requirement 8 is attestation thing. It's a core workload thing, in my view.
Well, it's attestation that really determines what, again, I don't want to get into solutioning mode here. I'm simply saying that we do speak to workload migration, right? And the fact that, moving from like a workload from one platform to another platform may change the claims about the platform. It's covered under 8. At least that's how I see it. Nicholas, do you agree?
I'm just catching up, and I hope I'm not disturbing the audio here.
No, not at all.
So my only point is, I always struggle if the workload identity, as you said, right, you're moving because of a migration of a DR situation, and then certificates or identities need to be reissued. So I'm just wondering whether this should be something more on the reference value side. So if you want to have for a specific workload some restriction that you validated as you attest, rather than having that physical location being part of your workload credential. That just sounds odd to me. But
well, so when your relying party evaluates workload credentials, so workload credentials is not necessarily related to your reference values or attestation results. This is something that the relying party sees, right? And what this requirement states is the workload credentials will contain claims about the workload, and they will contain claims about the platform. That is a requirement, right? You can't satisfy like German data residency rules without it. So how we going about it, that's not part of requirements. That would go into the reference architecture.
okay. But isn't that workload identity in general? That's my point. I'm just trying to map what is the additional or the reduced amount as you leverage confidential computing technologies as part of it. And so while I acknowledge that there are things that you need to identify that way, that's not specific to confidential computing and shouldn't be focused on the aspects which make it complicated or easier because of confidential computing, or because you cannot have the host interact with the running enclave as in other environments.
Right. So here's the thing. We cannot, I do not believe we can anyway, limit our discussions here to just confidential computing, narrowly defined, because ultimately the technology needs to be deployed in the real world, and the real world cares about things like physical location where the workload exists. So if we neglect to address this, then we are basically risk overlooking something that will make the resulting architecture not suitable for deployment. And like for this, we'll basically need to figure out, so if you attest your workload using your silicon and your quote, and then you separately attest your platform using your TPM, for instance, then you still need to combine the two results into one, do it securely, and that's what this requirement speaks to.
Okay,
Like
but what does it mean then? So basically, with the other 8. So if there is a DR situation and I have to move it from one data center to another, still
Yes.
within basically the same metro region or whatever,
Yeah.
then at that point, the workload credentials would need to change the next time something is sent to the relying party.
Maybe or maybe not, right? So this is why requirement 8 speaks to basically saying, look, if your claims change, then you need to treat this as a redeployment, as in you issue new credentials. And if the claims don't change, then you can preserve the credentials you have.
Right, but here you're saying that the claims, there's the need to include claims about the workload itself, as well as claims about the hosting hosting environment. So with that,
Correct.
the hosting environment becomes part of the claim. So if the hosting environment changes, like the physical location of the server, it would mean under 8 that it's considered a redeployment.
So, okay, so here's the difference. Imagine 2 scenarios. In one, your environment about the hosting environment says location Germany, right? And then you move from Berlin to Frankfurt data centers. Your claim didn't change, it's a regular migration. In the other scenario, you say location is Berlin versus location is Frankfurt or whatever, right? And in that case, the location does change. In fact, I may need to move rooms here because I was squatting. So if you just give me a second, I will reconnect in a minute. Yeah, sorry, I was squatting in this room. And, excellent. I'm going to move around. All right, thank you. Sorry, guys. I will rejoin in just a couple of minutes.
I'll take an opportunity to introduce myself really quickly and then ask a question. Hey, good morning, folks. My name's Alec. I'm going to be representing, I guess, temporarily from Microsoft, or who knows, maybe permanently. I wish I had Catherine to give me a distinguished introduction like Ari, but alas, I have to introduce myself. One thing I wanted to bring up during this conversation is 2 things that appear to be in tension here. So in hyperscaler data centers, we migrate workloads frequently just for balancing operations, and sometimes not because of a disaster, but just because of commercial concerns. For example, if a lot of VMs are on a particular node and we need to make room on that node for a very large VM, well, we move workloads, small workloads from that VM onto other VMs to increase packing density and then make room on the big VM. It's called live migration, and it's needed to manage hyperscalers at volume. The workloads are unaware that this took place. There's just a blackout that happens for a couple of microseconds, and then the workload is suddenly running on a new host. I didn't hear that in
another room. I just squatted. Okay.
Hey, Mark. So I didn't hear that in this discussion. So we kind of need to think of the attestation as coming from obviously the workload, the application, and then things that are part of the virtual machine, like VPN, and then things that are part of the physical hardware that are the actual processor, platform security processor. And these things can change. And so one of the things that we're struggling with is if an attestation measurement changes, but the application is still running, is that okay? So imagine a workload, as Mark described, that's running in an availability zone in Berlin, and we have to move that to a different availability zone in Berlin. The same virtual machine is still running. The same TPM is still running inside of that virtual machine, but the CPU that it's running on is completely different. The node that it's running on is completely different. Should we shut down that application and force it to reattest, or should we allow it to continue to use the identity tokens that it has in memory and that were moved over to the new node in memory? I'm not seeing that in this document here. I'm hearing discussion that makes it sound like attestation is always fresh, that I can always look at my attestation identity token and know the machine that I'm running on. But that assumption doesn't hold up in
so Alec, I hear you. If you remember my pedigree was in data center management before I left Microsoft. So I'm actually very much aware of live migration, and I was trying to speak to exactly what you're talking about. So
Cool.
if you actually look at so the scenario I just given, what I'm speaking to here is exactly the scenario of live migration. And the two examples I've given before I have to go change rooms was, and Nicholas, I see your hand up, so you're next. That's where I basically said you can have two live migrations that are identical, with the only difference is that in one case, you specify that your location is Germany, and you move from one availability zone to another within Germany, and nothing changed. And in another case, you decide that no, you need different claims. You actually want to know which city it's in, right? And in that case, exact same live migration changes your claims.
Right, but your workload is still running, so you're still using your identity token, assuming it hasn't expired.
Right.
But that identity token now has dated information. Right. No longer true.
So
yeah, I'm with you, Alex, there.
This is solutioning. And I'm saying that we should state a requirement, and then we should basically say, look, it could be that every time you do live migration, the control plane reissues your credentials, unless you can guarantee that the claims retain their veracity across the live migration.
Yeah, I don't think there's any way that the control plane can know, right? The control plane doesn't have access to your identity token. It might be confidential to the control plane. So the only thing that I think the control plane can do is, honestly, the only thing the control plane can do is shut down the workload and force it to reattest. And so that would obviously.
So
I don't want to go into further architecturing or microarchitecture, but I agree with you, Alec. It really depends on how paranoid your customers are. So we have some who would basically claim that as you did the live migration, you lost all credibility and you need to reattest, because you could basically make an attack by live migrating. I'm not saying, but that's the point. So I see Mark's point of saying you need to add that all to claims. My concern is how you ensure that communication, and how as a workload, if you, again, as a paranoid, think the control plane is rogue, the control plane could move you with your same identities, but actually being in an environment which is no longer valid. Be it a different city, be it a different version in your data center, being whatever. So I do believe that's a key thing to basically have these attesting on that level as you described. Even a live migration might avoid it
I want
instantly.
to draw a clear distinction between specifying requirements and recognizing scenarios and providing solutions. So this document is only about recognizing what problems may arise that we'll need to address, not how. The how goes into the reference architecture.
And in that spirit, I mean, I started to catch it somewhat, not going to solution space at all. I'm just trying to say that I think the relying parties might come in different sizes. And some of the relying parties might be okay with the workload being resilient enough, for example, from migrating even from Berlin to, say, Ireland, because they want the entire EU to be their claim of the data sovereignty. Or there might be different relying parties, maybe even targeting the very same running workload that would be actually sensitive to moving from Berlin to, say, Munich. So I just want to say, I mean, unless we as a forum don't agree with that, but I would assume we would need to have it in the requirements to at least coin a solution to that relying party conundrum, or explicitly say we have only a single identity and the more granular relying party viewpoint wins, and every migration, for example, from within the geographical boundaries of a city is a change of claims, ergo a deployment.
So feel free to propose changes to requirements as written, but I'm basically saying between 8 and 15, this should be covered. Maybe not as worded, maybe there's some sort of new wording to it, but I'm saying this, like there was an attempt to speak to exactly that.
Fair enough. So as it gets on GitHub, I'll probably submit an issue or PR to it.
Yeah, and this is again, the purpose of this working group is to discover all these issues, highlight these issues, figure out what we can do about them, right? And you know, hopefully arrive at something. So okay, so let's do that. Let's basically, you know, again, feel free to propose changes. We don't have to move the discussion to GitHub just yet. We can, you know, pick up this conversation topic in a week from now with some suggested changes. It might, you know, important to get the requirements right, so we all agree that these are the requirements. I am, however, like I'm probably one of the first people to speak to workload identity and migration, and I know it's a difficult topic, right? And I'm not yet at a point where you know, I can say, yeah, well, this is how we solve it. I know it's complicated, but it still needs to be recognized as such and documented as such, and then pursued as such. Okay. So let me reshare my screen. I think that got lost. The next thing I want to discuss would be the reference architecture. And I came across something that kind of made me stop and think. And it's covered, this document is very, very early draft. So in the assumptions, we talked about you know, secure RNG generation. This is kind of stuff we expect from the platform, right? Basically saying we are coming in, expect that the platform is going to be able to do certain things. And the first one is non-controversial, needs to be able to generate its own randomness. And the other one, it needs to be able to do quoting so that it can engage in attestation. The third one that is interesting. So so this came out of the governance SIG. In the governance SIG, we talk about how when you attest your workload, we need to attest not just the code that runs inside the, you know, the trust execution environment, but also the configuration of that workload. So for instance, you could have as a configuration your trusted root store, right? And a workload, the same code running with different roots of trust, configured with different roots of trust, will do radically different things, depending on, you know, who it trusts to submit inputs, who it trusts to go to get outputs, etc. So when you obtain your credentials, you should include in the attestation information or in what you measure the software configuration that the quote that measures the pages with which you load it is not going to capture. But then what happens if you say you took your credentials and then you sealed them to the platform, right? You started up, you attested with some configuration, and then you went and sealed your credentials to the platform. Now the workload shut down. The workload restarts with a different configuration and goes and unseals the credentials it has previously sealed and proceeds to work. Now you actually have introduced a security vulnerability. And I'm not exactly sure how to claw my way out of this one. This is where it comes into play. So I made a proposal, and this is under the workload lifetimes. So we have requirement 6. It's restated here verbatim. Basically, a short-lived workload. So to level set, when your workload starts up, if it needs to obtain credentials fresh every time it starts up for every instance, for short-lived workloads like Lambdas, your step functions, your Kubernetes pods, you are going to blow your verifier out of the water because you'll be basically flooding it with requests. It's like absolutely not a scalable approach. So the proposal, as I wrote here, basically says if you have a long-lived workload, go live your life, go obtain your credentials, and only renew your credentials when they're near expiration or whatever. But if it's a short-lived workload, the proposal was start in a special provisioning mode, go obtain some credentials, seal them to the platform, and then every time you start up again, just go unseal them and run. But that brings in the security vulnerability, and I do not know how to deal with it. So any ideas you may have, some of you are probably very, very technical and very close to this space. I wanted to discuss specifically this area.
Sorry, Mark, can you please elaborate when you said security vulnerability? Security vulnerability of what? Here you're trying to address the concern.
So my code is trying to do things. And a lot rides on who this code trusts. So for instance, your workload may be running with a set of roots of trust, right? The roots of trust. Who do I trust to send me data? Who do I trust for, who I established TLS with? All of that stuff, right? That's configuration of the code. And if you go look at the payload governance pattern from the GRC SIG, this is what we talk about there. You need to attest not just the code, but the configuration. Like I've had this long-standing, very long-standing, mantra that basically says bad configuration will make good code do bad things, right? So that's what this is about. So we talked about, and we captured the fact that for a properly governed workload needs to handle both the code and configuration. But now, if we're basically saying we're going to start a workload, seal, obtain some credentials that hopefully will last us a few days, and go seal them to the platform. But then the attacker goes, starts that same workload, but with a different configuration. Sealing to the platform, I don't believe captures that. Right? So like sealing to the platform means if your code hasn't changed, then you'll be able to unseal data previously sealed to this instance of the workload. But it doesn't capture configuration, so we may have actually a serious problem.
So help me understand, what do you mean in this context with sealed? Because normally the assumption, in my opinion, would be the workload coming up again is attesting and getting the unsealing secret from that. Because otherwise, where would you put that sealed or unsealing secret persistently? I'm lost there.
Right. So I believe the sealing to the platform function, at least the way I remember it, doesn't require reattesting. It's a local operation. So basically, your workload starts. It has basically certain code pages in memory. And it can basically say to the hosting platform, seal this data so that when I start up again, I can decrypt it. And only I can decrypt it. If some different code starts, it cannot decrypt it. That's the sealing to the platform function. But the problem with that is if it's similar to PCRs really in the TPM, right? But in this case, you don't have PCRs. So now you unsealed, but you started and there was like different configuration that was given to you. All of a sudden, you are not doing the same thing.
So the workload.
I don't know. Is that a Linux function or is that a processor?
I think it's one of the platform primitives. It certainly exists in SGX.
But then, Mark, I think the short-lived workload is not much different from a long-lived workload, which has the configuration changing at runtime. Because in the end of the day, what you are doing is really you're snapshotting your state. You're sealing the entire thing. You could very well seal your own configuration, and then upon reinstating the workload, you're the author of the workload, it can retrieve its own configuration, do a sanity check, and if it fails to compare against what it has sealed before, just refuse running. There is, of course, a concern with that because the entire sealing, this is the biggest vulnerability I see. Sealing itself in the contemporary platforms doesn't give you monotonic counter protection. Like you don't get to track passage of time, and whatever you have sealed at same time T1 and T2 would be perfectly valid, and the attacker might be able to reverse the passage of time and serve you your own configuration, which is from the past. That could be, of course, strengthened by introducing another platform requirement to give you a monotonic counter property. It is a possible technical implementation, although it has to be said, it's a heavy one from the technical standpoint to exert. But I would still say, yes, I definitely see a concern with being able to track the management of the life cycle of the configuration.
Yeah.
I wouldn't say necessarily that you don't have nothing. Like, you still get to see this is your configuration and not something that somebody has subverted.
I like this. I actually like this a lot. I think asking platforms to introduce monotonic counters is way too heavy a lift. I don't think we should be attempting that. For one, you need to basically go to Intel, AMD, NVIDIA, and ARM and have them all figured out. And then it's like how long until the silicon is taped out and shipped and all this other stuff. So like this is absolutely last resort. But I do like what you're saying in terms of that it should not be a simple, call the seal and unseal API. It should be something that actually takes whatever you chose to attest as part of your configuration. You should also make a note of that. And the workload itself, the code of the workload should check this, when I sealed with this configuration. And when I'm unsealing, I need to make sure that the same configuration is unsealed. And unless that, the code itself defends itself against this attack. I think that can work. And this is exactly why I love having you all guys here, because we can then highlight and fix all these problems and document solutions. And that becomes our reference architecture.
Mark, sorry, Jack has a question here. Jack,
Yeah, please. Mm-hmm.
So I wanted to add a perspective here. So hello, everyone. I'm Jag from Oracle. So the sealing operation reminds me of how TPM operates in some cases where a provisioner can save a secret and then seal it to the TPM by saying that, hey, you have to release the secret only if the measurements or the PCRs match a particular value. That's what I understand as a sealing operation. It's not like an interface where you say, hey, I'm sealing a secret, give it back to me later. So the TPM will automatically release the secret when the workload or the platform's state matches a provisioned state already. So I think that we should probably make a distinction between sealing and storing, and we probably should also define what sealing is so that it's not confusing.
Fair enough. So again, folks from Intel, AMD, ARM, if you're on the call, you can speak to this right now. So the ability to seal data to the platform in the confidential computing sets. I don't know if it's certainly we don't have PCRs, but certainly I know it's one of the functionalities on SGX that you could do. If that does not exist, if you cannot save some sort of state and have another instance go later and decrypt it, then we are going to have to come up with something else to make sure that short-lived workloads, don't bring verifiers down. And then we should probably exactly document what sealing to the platform assumption in the reference architecture assumes. Yogesh.
Yeah, I mean, I kind of agree with what Jag has mentioned. If you want to bind a particular workload configuration and workload measurements to the platform, then you need some kind of a computation mechanism where you compute a sequence of things in your workload and then create a secret internally and then lock it to the platform so that next time if somebody wants to unseal or get asked for a permission to run on the platform, they need to produce exactly the identical secret so that it can unseal stuff.
Yeah, but further, I really like this idea, and I think myself or somebody else should document this in the reference architecture. We'll also make it part of the payload governance, right? So this is very important to note. If you're going to use the seal API and then you use the portion of your configuration to a test, then you need to ensure that you're running in the same configuration as the one you used to seal in order to unseal. And this cannot be done by the silicon. This needs to be done by effectively a wrapper API inside the workload itself.
Yeah, Alec wants to share something.
Yes, Alec.
Yeah, I just want to keep the conversation super specific to what things can happen on the silicon, what things can happen in the paravisor at the virtual machines TPM layer, and then what things happen in the workload. Because I'm hearing the conversation kind of move between those layers a little bit. I know not all CPU vendors have sealing primitives today. I mean, they're all talking about introducing them in future generations of their hardware. But today, I don't think all silicon vendors have sealing primitives. Like there's no TPM 2.0 standard that gets you all the way down to the platform security processor. So some of the things that you folks are talking about are done in software emulators, right? The TPM is a software emulator that runs in the VM, which brings trust into the platform. So I'd love to see, and I'm trying to add some comments here, and sorry for not joining the meetings earlier, but I'd really like to see specificity of when we talk about hardware, we're talking about physical hardware or virtualized hardware, as in the case of a TPM.
Now, we will definitely, a good suggestion, we will definitely document what we expect of each layer, right, expectations. But in this case, when what I mean by say seal to the platform, when me, Mark Novak, speak to in this document, sealing to the platform, I speak specifically about confidential computing primitives, not TPM.
Then I don't think there's sealing primitives that we can use that get you, I mean, we can in the paravisor obviously add report data to the attestation evidence, and then that gets signed with the CPU key.
Mm-hmm.
But
right.
That report data section is owned by the cloud provider, right? So so you bring in the trust of that platform. So I just kind of want to keep the layers separate, so we know when you're trusting Intel, ARM, AMD, we know that, and when you're trusting the cloud service provider, Azure,
no, we're definitely talking about trusting your silicon and primitives provided to the workload by silicon, much like RNG.
Got it. Okay, well then we can't. I don't think we can talk about sealing, and I'd be happy to be proven wrong here if there's somebody from Intel or AMD or ARM CCA in the room. But to my knowledge, there are no.
Can we then put a call out for next week? For all silicon vendors to tell us if sealing something by silicon to a workload to the trusted execution environment, if it's a capability that exists, if it's on the drawing board, because if it's not ubiquitously available, then it's back to the drawing board. We need to figure out how to issue credentials to short-lived workloads. Nicholas.
Here, just following off of what Alex said, sorry, Nicholas, I'll let you go next. I mean, I can for sure tell you SGX has sealing. TVX, as far as I remember, I'll have to recheck, but I don't think we have it yet. But Microsoft's approach with the paravisor, I mean, TPM on this abstraction layer does give you sealing. Now, whether TPM is anchored all the way into a primitive that trusted computing provides or confidential computing provides is, of course, of essence to this discussion. But I wonder if we should over-constrain and say the sealing itself has to come from a hardware platform, or whether it's just a platform which happens to have, either direct or indirect ties to the hardware. Because if we indeed say a very strong statement that we need to have a hardware-based sealing, that might limit the number of hardware which supports it right off the bat. But I guess this is a discussion to be had next week to just inventory what we have.
So Mark, are you going to make a note of it somewhere in the open issues or something?
I will definitely make an open issue out of this. We have 15 minutes now. So let's put a call out. Again, I don't have the list of participants in front of me right now, but we have 4 silicon vendors that I can think of: NVIDIA, ARM, Intel, AMD. Let's make sure we either on the call we contact them and ask, or maybe review some documentation. But by next week we should have an idea about the sealing capabilities. Paravisor, I probably honestly just have to look, read up on to understand if you're implying trust to your CSP in that. And finally, Nicholas, one last comment from you, because I need to move to another topic that I want to discuss this week, and that has to do with IETF. So please go ahead.
It is interesting that you don't consider IBM to be a chip
silicon
vendor, or having confidential silicon vendor, or having confidential computing.
I wasn't aware that you guys offer silicon, but if you are, then yay. Awesome.
Well, that's why I'm joining this meeting. IBM Secure Execution, and you have the ability to encrypt workloads against a given sealed secret in an HSM or in the CPAC-F.
Okay, fantastic. So great. And then perhaps you can provide some references to your specs, and we'll include them in our library. Yet to exist library of specs that we'll be considering when designing the reference architecture.
Yeah, that was not the reason to raise my hand. I was just curious. I mean, signing in the TPM for me doesn't work as sealing of the secret. That was my initial comment I wanted to make to Alec, right? So for me, these are two things, and so that's why. So
we're not talking about TPM here. Like TPM is is for testing the platform. I can't imagine how TPM can help a workload seal things too, especially considering how many different workloads will be on a single CPU. But okay, so sorry, I'm just checking many chat messages here. All right. So okay, so we'll have an open issue of trying to figure out what the sealing capabilities are, and then we will revisit the workload lifetime issue once we understand that. So the next thing, Yogesh, you're probably my key reference material for this, but I really do believe that we need to start working with the Whimsy working group at the IETF. And that they did not appreciate my presentation at the Bangkok IETF because we were not going through regular IETF channels. We did not submit an informational draft. They basically said, "Who are these bozos who are doing something related? We're not a confidential computing group, etc." So all very understandable. So I'm perfectly happy to play by their rules. Now I would like to have a discussion about what it is that we could submit to the IETF in Madrid. Need to look at the deadlines, need to look at sort of the logistics, the process, like all of it. So I'll just throw one idea out here, is that for the Madrid IETF, all we supply is an informational draft that articulates our requirements too. So how to make trustworthy workload identity, like how to make workload identity, Whimsy style workload identity trustworthy, and what are the kinds of things that need to be present, or some form of that. Basically saying, no, we do want to work within Whimsy constraints, but we would like to do it in such a way that we don't trust the platform where Whimsy does. And again, that's just a draft idea, and I want to hear from you guys on anyone who's actually worked with the IETF in this capacity, and how we should best approach this.
Yeah, so I can shed some light because I work closely in IETF with the RATS working group. So normally, if you first have a birds of feather session where you introduce the topic, if there is sufficient audience, then they say, yes, this is a valid topic, we should produce a draft for a completely new thing. But here it's a slightly different because Whimsy is already talking about workload, and we are talking about workload in a specific setting. So the working group is already there. If they have a sufficient buy-in on our topic, then I don't think they will have any objection in us producing a draft, actually.
So you're saying a BOF session has to precede submission of a draft?
Yes, and I recollect looking at your video, Mark, our presentation, what we did together. They said that you should publish draft under Whimsy with your own thing as a separate draft, right? That's what the conclusion was, right? If I remember correctly.
I think so. See, they did not mention the birds of feather session, and I
Yeah.
guess my initial thought was if we do birds of feather at Madrid, then it puts off an informational draft effectively until Montreal, which is another 4
Yeah.
months. Okay, and maybe that's what needs to be done. But if at all possible, I would love to have a draft ready for Madrid and say 4
Yeah.
months and get some discussion. But again, anybody else on the call has any opinion on this?
So, Mark, I will be traveling to ITF this time in Madrid.
Yeah, and
I
so
be
will
there.
I. I'll be there.
Yeah. So I'm okay to produce a draft with just requirements because I was thinking we will have some architecture as well in there. So I started working on a draft on a particular repo. But if you think we don't have enough time to prepare a
Is there a deadline? Can you?
yes,
What's the deadline for the draft submission?
normally submission of draft is around 3 to 4 weeks before the cutoff date of the ITF. So it will be sometime in June, towards mid-June, because the
Okay,
ITF
so
is start. Yeah, we
so
have
we have
time
about
actually.
six. We have about 6
6
7
weeks.
weeks.
Yes, yes.
And if we agree on requirements, then publishing some form of these requirements as an ITF draft might, or maybe a subset. We don't necessarily need, like, unless Whimsy really cares, we don't need to capture those. But we could.
Yeah, I mean, what we should ideally capture is at least the requirements as what you say, plus certain use cases where these requirements fit in. Why we are trying to create this, why Whimsy as a standalone thing is not sufficient, and that's why because we have these new requirements, and these requirements are related to these industrial use cases, practical use cases where they fit in. That is the bare minimum we should do. And then say for these requirements, we would be working on an architecture which we will present in the next ITF.
Exactly. I think that's a more conservative approach, but also fast enough for because if they have strong disagreements with requirements, then building an architecture around requirements that they push back on, would not bode well for us.
Exactly. So I think we should document the requirements as what we have been doing and prepare a draft out of that. And use cases also is very relevant because we didn't generate these requirements from thin air, right? We have some concrete, every industry in our organization, we have some use cases for which we need these which are tied to these requirements, right? So we should write those use cases also. Yeah, because Whimsy also have certain set of use cases, and then we can clearly say, look, your use cases are different, our industry needs are different, our use cases are different, and that's why we have these requirements. And once they agree, then we can propose an architecture. But if they don't, yeah.
Okay, so I would say at this point in time, if you can spare the effort, perhaps start taking our requirements and converting them into effectively an informational draft. And then let's work with the ITF to ensure that we, get our slot in the next Whimsy meeting and get to present these.
Yeah,
Okay,
I will write
sounds good.
once we have some draft. Towards the first week of June, I will write to the Whimsy chairs to give us a slot. At least, I think we should try for 20 minutes, I suppose, for a slot.
Yeah. We should.
15 minutes of
and then the
presentation.
thing is, hopefully the stuff that happens outside of the Whimsy session, like talking to other people, this is why I'm going to be there in person to have more than the 10 minutes. Yeah,
absolutely. Side meetings are very important. Yes.
Okay.
Yeah.
All right. I don't have anything else, folks. So we have 5 minutes left. Anything else you'd like to bring to the table now? Okay, hearing none, make sure you are noted as an attendance in the meeting minutes. I will provide some sort of a summary of our discussion today. I will, at this point in time, commit our requirements to GitHub, and then feel free to make changes. Either the pull request when that comes out or to the Google Docs now. And we, of course, all requirements can be reworded and changed at will, so long as we get a better set. But hopefully by the time we get down to reference architecture in earnest, the requirements will be, sufficiently stable that we don't keep chasing them. All right.
Alec has something to ask.
Yeah.
Here's a use case that I've been asked to look into. So in the platform as a service, software as a service world, customers who have sovereignty requirements are starting to get interested in confidential computing. And so they're starting to look at attestation as being something that's necessary. So this I think this general idea that Mark has launched here is a really good one. So what they really want to know is, can a hyperscaler cloud service provider provide evidence, attestation evidence, that a service that they are using, an identity service, for example, is running entirely on confidential computing hardware. And this is obviously a very forward-looking requirement. So the idea is, I'm going to use Okta, for example, and I want some attestation evidence that Okta is running all of their identity services. And I don't know about Okta, but I know there's probably hundreds of services running behind Okta. Is all of that confidential such that it meets my sovereignty requirements that are based on my political jurisdiction in the Middle East, for example? Does this working group aspire to setting some sort of guidelines that would help customers answer those requirements?
So this definitely belongs here, sort of one leg in this SIG, and the other leg is in the governance SIG. So we'll need to ensure that there are governance requirements around it, and also how these requirements are satisfied. So we're going to meet tomorrow, talk about JRC things, right? Or is it Wednesday? Wednesday. Yeah, tomorrow is Wednesday. Never mind. Yeah. So we'll pick it up there as well.
Yeah, the political stuff is really easy, right? They just wave their hands and say all data will be kept confidential from these cloud service providers that have their headquarters in their geographies. That's an easy statement. But then when you start digging into the details, and I've been leaving comments in the document.
So this is what yes, it's in scope. We will dig into this. All right. I'll see you guys. Thank you for your participation. Thank you for all the inputs, and talk soon.
Nice meeting you.
See you.
Bye.
Nice
Bye-bye.
meeting.